Welcome to Hartman Math. This is lesson 10.7, polar coordinates. As it says, most of the time we represent our coordinates in terms of x and y, which is in the rectangular coordinate system. Now we're going to take a look at the polar coordinate system. Well, where our polar coordinates are r and theta. And this time r is a directed distance, kind of similar to how we were thinking of P in terms of parabolas, in terms of the conic sections. So r is a directed distance, could be positive, could be negative. Theta is a directed angle, which is kind of a standard trig angle. Sometimes they rotate positive, sometimes they rotate negative. So we've got r comma theta. So r is the directed distance from O, the origin, to our point P. So we're going to reference everything in terms of the polar axis. If you think in terms of trigonometry, that would be like the positive side of the x-axis, our initial side for our trig angles. And r would be the distance from there to there, and theta is that directed angle. Example number 1, we're going to plot points in the polar coordinate system, starting with the point 3 comma negative pi over 3. 3 is the r, negative pi over 3 is the theta. You want to start with the theta, so we're going to start there and think of the angle negative pi over 3. So we're going to rotate from our polar axis here clockwise. Pi over 3 is a distance, so it's going to go right in there. You know that would be essentially coterminal to 5 pi over 3. That's where we're thinking. And then 3 is the directed distance away. So since it's positive, we want to go in that direction. 1, 2, 3, and put our point. All right, for B, negative 2 is the r value, the directed distance. Pi is the angle. So we'll start with pi. And then we're going to go 2 units, but not that direction. Negative means go the opposite direction. So instead of heading here, go directly opposite 1, 2, and put our point. Example number 2. See that there would be multiple representations in the polar coordinates for the same point. So if we're looking at, let's go ahead and plot this point and then come up with 3 additional ways to represent that under the condition that our angle has to be between negative 2 pi and positive 2 pi. So first of all, where is this? Start at the angle. Where is 11 pi over 6? We're going to go 2 units, but the opposite way. So instead of going here, we're going to shoot across, go the other way. Okay. Now, pause the video here and see if you can come up with 3 other polar coordinates under this condition that land you right there. All right, you must be ready. So let's think about it. Probably the easiest one would be if we were rotating this way, 5 pi over 6 to 2 comma 5 pi over 6. We could have the angle go this way, negative 7 pi over 6. Go 2 units that way. There's got to be another one that's a negative. So let's see, what's another representation for this angle besides 11 pi over 6? How about negative pi over 6, but shoot opposite? And those are the 3. So this is how we would convert from polar to rectangular and rectangular to polar. The x-coordinate, we know the polar, if we know r and theta. The x-coordinate in our regular rectangular coordinate system is r times cosine theta. The y-coordinate is r times sine theta. If we know x and y, we can find theta knowing that y divided by x is the tangent of theta. Now, when we use inverse tangent, we're going to have to be really thinking in terms of the x and y given. What quadrant would that be in? What was that going to mean for theta? Do we need to adjust it? And then the square of r is equal to x squared plus y squared. So that's how we're going to find the r. Example number 3, we've got a polar coordinates, root 2 comma 3 pi over 4. Find the rectangular coordinates x and y. X is going to be r times cosine theta. What's the cosine of 3 pi over 4? Negative root 2 over 2 multiplied by root 2, it's going to be negative 1. The y-coordinate, root 2 times sine of 3 pi over 4. The sine of 3 pi over 4 is root 2 over 2 times root 2 is 1. So our coordinate pair, x comma y, negative 1 comma 1. Let's go convert from rectangular to polar. So find the angle, y divided by x. To find r, r squared is equal to x squared plus y squared. So if we started with our angle, tangent of theta, y divided by x, we might recognize that. We might not need a calculator and say, all right, where is tangent going to be negative 1 over root 3? And where are we? In which quadrant? Going left and up. So I think we're going to say that's going to be 5 pi over 6. Now our r value, and if we are going 5 pi over 6, we're going to want a positive r value. Square root of x squared plus y squared. It's going to be the square root of 4, which is 2. So 2 comma 5 pi over 6. Clearly, as we saw in a previous example, there are others, but this is definitely the most basic and the expected route to go. Example number 5, what about not just doing coordinates, but equations? So we have a polar equation that says r equals 7. Can we get that into rectangular form? So we're just going to kind of algebraically manipulate this. So I'm thinking we definitely have a conversion for r squared. So what if we just started by squaring both sides? And then r squared converts into, by conversion, x squared plus y squared. And in rectangular form, what is this the equation of? It's a circle. R equals 7. A radius of 7, circle. There we go. All right, part B, theta equals 5 pi over 6. Well, our conversion has tangent of theta. So why don't we just take the tangent of both sides? So tangent of theta equals, now the tangent of 5 pi over 6, by our knowledge of the unit circle, is negative 1 over root 3. And now we can replace tangent theta with y over x. And that would probably be an acceptable answer. We might be more familiar with something like a y equals mx plus b model. If we get the y by itself, multiply both sides by x, we get something like that, or negative 1 over root 3 times x, where we would see that this is a line, and the slope of the line is negative 1 over root 3, with the y-intercept of 0, 0. All right, part C. Well, we already saw something similar, but it's a little bit different here. So if we kind of squared both sides, The right side's pretty complicated there, and we could get x squared and y squared here, but we can't get rid of the theta. So maybe that's not the right way to go. So let's think of another way. So think of conversions, if we kind of ignore this side for a second, that involve the r. Like r cosine theta and r sine theta. Now of those two, now let's look over here. Which of those two is more likely? R cosine theta or r sine theta? Since cosecant theta is closely related to sine theta as a reciprocal, I think that's the one that we want to go to. So we'd like the left side to become r sine theta. So let's multiply the left side by sine theta, and therefore on the right. So let's multiply both sides by the sine of theta. And since we're multiplying the right side by the reciprocal, you're definitely going to get 1. And what is r sine theta? That's y. So we got a horizontal line, passes through 0, 1. That's it for today. See you next time.